notice that we have some X and Y values that are going to come from video analysis. Now, the first portion here is going to be, I'm not sure if this is going to be for Bernoulli or if it's going to be for the kinematic equations, but any two ways. We're going to need a certain amount of data sets, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for Bernoulli's, and then we'll need 1, 2, 3, 4, 5, 6, 7, 8. Yep, 9, 10. We'll need 10 for Bernoulli's and then 10 utilizing the theory for or kinematic theory. So you'll notice that we have our initial velocity being calculated here for Bernoulli's equation, initial velocity calculated here, as well as the time of flight for the kinematic equation. And then we're going to look at the percent difference between the two. So we're utilizing Bernoulli's equation. Bernoulli's equation is very, it's ideal. It's for an inviscid fluid, which means that there's no viscosity associated with it. Now, although water seems to flow fairly easily, it still has a certain amount of viscosity associated with it, and just make sure that you understand that. We're going to take the, we're going to use the kinematic equations to calculate the initial velocity as well. So when we do that, we're just going to compare the two, and that's where we're getting our percent difference. So what I want you guys to do, I want you to go ahead and download this video and open it in video physics. So I already have it open in video physics. Make sure that you rename it. I put in Bernoulli, Brass, Eric. You guys make sure you put your name in there. I'm going to go to origin and scale, and I've not scaled this. So I want to go ahead and move my pixel bar down, but I am going to use, I'm going to set my origin to where the water comes out. Now you can't really see where the water is coming out because I have a piece of tape over the water. And so I'm just going to let it play a little while. And I'm going to stop it right there. I'm going to set my origin right here. I'm going to slide in. And it's right where the water is coming out, okay? Oh, you didn't crash. You rascal. Where are you? Give me 1 second, folks. There we go. So we're back in stride again. All right. So we're just going to set our origin right here. That's our 0, 0 for the X and Y. And we want to set we want to calibrate the tick marks on there using this ruler. So this is a 1 foot ruler. And we know that there are 0.3048 meters to every foot. Okay? So now we have a calibration here. Just take a snapshot and make sure you guys upload that. It's difficult for me to analyze the errors that are occurring in your work without having these snapshots. All right? If there is an error. A lot of times you guys don't have errors. So what we want to do is we want to go ahead and we're going to take 10 points or 10 sets of data between this location and this location. And so I guess that would be kinematic, okay? So I'm going to go ahead and tap once there and then tap once here. The time isn't really going to matter at this point. You couldn't tell what the time is going to be anyway, because these water molecules, if you could slow this down enough, it looks like it's a stream, but they're actually bunches of water, okay? But they're it looks like it's all continuous. But if we could slow down the video enough, you would see that it's not. So let me go ahead and frame forward just a couple of times. Tap again in those locations. And I'm just going to frame forward 2 more times. We should have enough video to do this. So that's my 3rd set. And the water does change a little bit, the distance. Another point there, another point here, another point there, another point here. there. Now, I don't know how many points I have, so I'm just going to go up here and look and see. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I need 2 more points, or 2 more sets of data. Just going to frame forward 2 more times. All right, and let me just double check. Yep, let's see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Beautiful. So that's going to be for our kinematic. So we know the first set of data is going to be kinematic. Now we need some more data. And if I just let this play a little bit, you're going to notice when I come around. At first I thought the water would be at this level right here, but it's not. It actually went up a little bit once I started flowing it. So I went over and I made another mark. So we're going to take our values from this location to this new mark right here. So I'm just going to pause it. I'm almost at the end, but that's okay. I can stop right there, and I'm just going to tap once right here, and then tap right here, and I can tap here. I can just do this. It's actually framing forward for me right now. So this is actually acceptable. For Bernoulli's equation, we're only concerned with what's happening in the y. Remember, it's coming from the conservation of energy. And I want to say subsequently from the, what do you call it? Gravitational potential energy. So remember, that's only determined by what's happening in the y direction. We don't have gravity acting in the x direction for our purposes. Some people will argue, or some people have theoretically found that we do, but I'm going to fight about that. Let me see. I can't even tell how many points I have here. Can't really make it bigger, so I'm going to make sure that I have more than enough. And that's because I was talking. So that should be... If I were to spread them apart, we definitely could see a lot better, okay? So, but all we need are 10 sets, okay? So I think that should be enough. So you guys make sure that you all upload this data and upload your, when I say upload this data, make sure you upload your video with points. And we're just going to move our data file over now. And upload your screenshot. So I'm going to go to graphical here. I know I'm going fast. I'm expecting you to be able to handle what I'm giving to you by now. Let's go ahead and change the format of our data here, and I'm going to change it to table. And so you see we have our table here. Let's just go ahead and share this with Microsoft Excel. Open in. And Microsoft Excel is located right here. Okay, so it should open up. All right, there we go. We want to convert and edit and make sure that we put this data set into the folder under consideration. I want to say under consideration, but the folder that's related to this experiment, and it's Bernoulli's equation. So here we go. I'm going to save that. Only thing we need are X and Y values. And let's go ahead and let's make sure that we're pulling over the appropriate data for the appropriate calculations. So I'm just going to double tap on each one of these column links. Make sure that I can tell what they are. That's our X, that's our Y. And I want to get rid of stuff that we're not considering, so hide the time and the velocities. And now let's consider let me see, the first 10 points, if you guys remember. See, I have 0, 21, 0, 21, 0, 21, 0, 22, 0, 22, 0, 20. All right, stop right there. The first 20 points, I'm just going to give them a color, okay? And then I want to do the same thing for the next points. And all we need are the first 10. So I'm going to go 0. I'm checking the data as well. 0, 6, 0, 6, 0, 6, 0, 6. So from 22 to, I guess, All right, that's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And I'm just going to give this another color, a different color. So this will be the data sets that we are going to use. I don't necessarily have to do all of this, but I know that this is going to be for the kinematic equation. So I just want to put and I'll just merge those. And then I want to do the same thing here. I'm going to insert above, and I am going to call this Bernoulli. Bernoulli. I'm going to highlight both of those, merge them, and make them white again.